The second concept that we wanted to talk about is the molar mass or molecular weight or formula weight. Okay, so according to the periodic table, mass of hydrogen, atomic mass of hydrogen is 1.008 AMU. And according to the periodic table, oxygen is 16.00 AMU. If two hydrogens and one oxygen are chemically combined, the weight of that molecule or the mass of that molecule would be 16 plus 1.008 plus 1.008, which will amount to 18.02, approximately 18.02 AMU. Okay, so now remember 18.02 AMU is the mass of one H2O molecule. So if I was to represent oxygen as this circle and hydrogens have these two circles, so if you take one molecule like this, the mass would be 18.02 AMU. Okay, going back, learnt before, AMU is atomic mass unit. It is just a unit of mass, just like milligram or kilogram or gram, right? Just like any other unit of mass. And what is the relation between AMU and mass? 1 AMU is approximately 1.66 times 10 raised to negative 24 grams. Right? And it's understandable, right? I mean, 1 AMU is 10 raised to negative 24 grams. Because atoms and molecules are so small, you can't take a gram scale or a milligram scale to weigh them out. So you need a much, much, much smaller unit. And so AMU, which is 10 raised to negative 24 grams, is chosen. So one water molecule, just one of this, one molecule, just one molecule has a mass of 18.02 AMU. Okay, now what can you do with just one water molecule, right? What can you do with it, right? You can't do anything with just one water molecule. This is too small for any reactions or anything for that matter. So what do? Instead of taking one water molecule, we try to work with 1 mole of water molecules. 1 mole of water molecules. Or let me put it this way, it will be much easier for you to see it. 1 mole of H2O molecules. So that means you're working with 6.023 times 10 raised to 23 H2O molecules. So you've taken so many molecules. So this will be of significance because it's a lot of molecules, so some reaction can be shown. Now, mass of one H2O molecule is 18.02 AMU. The mass of 1 mole of H2O molecules, that means the mass of 6.023 times 10 raised to 23 H2O molecules will be 18.02 grams, and this is something that we can deal with. You can take a balance and you can weigh it out, because you can weigh out grams. So use the conversion factor and try to work this out. If take a minute, pause the video and try to work this out. Mass of 1 H2O molecule is 18.02 AMU. What is the mass of 6.023 times 10 raised to 23 H2O molecules. Okay, and you will get a certain answer in AMU. Convert that AMU to grams and you will end up with 18.02 grams as well. When you are asked to find out the molar mass, so that means what is the mass of 1 mole of a substance, any substance, atom or molecule or ion or whatever, you have to get the numbers from the periodic table, atomic masses from the periodic table, add them up. So if you were to get mass of carbon monoxide, for example, carbon is 12.01, oxygen is 6.00, get this and you will get the answer as 28. And if you are asked to find out mass of 1 mole, or if you are asked to find out the molar mass of 1 mole of a compound or ion or a molecule, that will be whatever number you get in grams. But when you write the units of it, if somebody asks you, or if the question is what is the molar mass or molecular weight or formula mass of a certain compound, you give the number and you give the unit as grams per mole. So that means you are conveying that every mole of this compound contains this many grams of this compound. We will do a lot of exercises in class.